Okay, so this is a second kind of more difficult example on conditional probability. So a factory has three machines, X, Y, and Z, producing retrospectively 50%, 30%, and 20% of all components it makes. From established data, 4%, 6%, and 3% respectively of the components produced by these machines are defective. Okay, so this is actually what I'm asked then here. Okay, if a single component is selected and found to be defective, so this is the probability that I know, this is the condition. Okay, so the probability of A is it is defective. Calculate the probability that it was produced by machine X. Okay, so probability B is produced by X. Okay, so what I'm actually looking for is the probability that it was produced by X, so probability of B, given that I know it is defective. Okay, because you know it is defective, you're told it is defective. Okay, so there's a couple of different ways to go about this question. One, and I want to bring you back to your junior cert probability, is to look at a tree diagram. Okay, now there is a couple of different ways and you don't have to use the tree diagram. I think this is a really nice way because we are talking about three different components. So you're talking about component X, which has a 0.5% chance of going to, Y, which has a 0.3, and Z, and it's got a 0.2% chance of it being produced by Z. Okay, then X can be defective, I'll just use D, or not defective. Okay, for X, there's 4%, so 0.04. Okay, now I'm only worried about them being defective, so I don't have to worry about the non-defective, but if I wanted to put in my probability here, it would be 0.96. For Y, the probability of it being defective is 0.06, and for it being not defective is 0.94. And then finally for Z, the probability that it is defective is my 0.03, and the probability that it is not defective then is 0.97. Okay, so given that I'm not actually worried about it being not defective, because my question is only asked if it is defective. Okay, so if it's defective and produced by X, it is 0.5 times 0.04. Okay, because it has to be produced by X and defective. So that will give me 0.02. Okay, so that was the 0.05 times the 0.04. We should hopefully remember how to use these tree diagrams. So they're always and. So it's this and this. Okay, to get my final probability. The probability that it is defective and produced by Y, because remember, I need the probability that it's defective at all. So I need the probability that it's defective by X, Y, or Z, is 0.3 times 0.06, which is 0.018. And the probability that it is made by Z is 0.2 and defective, so times 0.03, and I get 0.006 here. Okay, so these are all the probabilities that it is defective. Okay, so PA, the probability that I know it's defective, and it can be any one of them, so it can be defective by X or by Y or by Z, so I'm adding them all up. Adding them all up, I will get 0.044. Okay, so I now know that the probability of A is 0.044. Okay, and it makes it just a little bit easier with my tree diagram here, I think. Now, the probability of B, given that A has happened, is the probability of A intersection B divided by the probability of A. Okay. So the probability of A intersection B is nice and easy actually, because it's the probability that it's defective and by X. Okay, so defective and by X is actually just this one here. So 0.02. Okay, and if you don't understand that, just go back a little bit and try and make sure you do understand where I'm getting the 0.02 here, because A intersection B means it is defective and by X. Okay, don't get that confused with the conditional probability. The conditional probability means that you pick up a device, it is defective, and you want to know what's the probability that it came from X. Because if I pick up any product, it could be from X, Y, or Z. I want to know what is the probability that it came from X. Okay, and then over the probability of A, which we just worked out to be 0.044. Okay, and I will get a nice simple 5/11. And again, because my answer was given in percentages, okay, that works out at roughly 45%. Okay, so 45% chance that if I pick up a device that's defective, that it has come from X. Okay, and again, spend some time with this example. It is important to be able to understand conditional probability.